Hello, this is Dan Alford with ARC Specialties.
And I'm Jim Walker.
Jim is a welding technician in our research laboratory. We've been doing a great deal of work on additive manufacturing. And if you think about it, welding is the original additive process. We've been doing this for over 100 years. So we've done several processes: electroslag, gas tungsten arc welding, plasma welding, submerged arc welding. But the sample that you made this week, how did you do this one?
This was gas metal arc welding, so MIG with wire, 035, 316 LSI wire. And the interesting part about this one is we decided to use some hydrogen in our shielding gas.
So what you're seeing on the video here is robotic additive manufacturing using short-circuiting transfer, gas metal arc welding with stainless steel wire. So we're going from a round to an oval. We start out with a base plate made out of steel. What's the deposition rate on this one, Jim?
1.6 pounds per hour.
So relatively low deposition rate. This is what we'll do for fine details. And how are you controlling the interpass temperature to maintain the mechanical properties?
For this specific part, we just had a simple cool down time. But I've used in the past copper platens, water-cooled copper platens, as well as air blasts to increase the cool down rate.
And so what we're doing is we're building upon some research we did back in 2017. That paper is available on our website as a white paper. It's also kind of a synopsis of it was published in the Welding Journal in August of 2017. What we did was we did a lot of work confirming that we did not degrade any mechanical properties of the base metal with the use of hydrogen. So the whole point of hydrogen is it reduces oxides. When you're using shielded metal arc welding like stick welding, you have a flux that will reduce the oxides. And oxides have a much higher melting point than the base metal itself. So you have to get rid of them somehow or another. You either remove them mechanically, chemically, or reduce them with a flux. And the hydrogen acts as a flux. And how much percentage are you running on this?
This is 1% hydrogen.
So well below the flammability limits.
Yep.
No danger.
Nope. No exploding robots. No burning robots.
No Hindenburg.
No Hindenburgs.
Okay. So I believe 5% is flammable. So we're down at 1%. And yet it will remove the oxides. When you're doing additive manufacturing, the big problem is each layer creates a certain amount of oxides, and these oxides float to the surface. And you'll typically find these in the cross sections of the weld in the form of weld defects like lack of fusion, nonmetallic inclusions. But you tested for that, right?
Correct. We made a sample for destructive testing. We then cross-sectioned it, mounted it, polished it, and etched it, and so that we could micro-examine the grain structure for discontinuities, lack of fusion, porosity, non-metallic inclusions, and we found none of that.
And so this is the photomicrograph. I see no oxides at all. You're going to publish this as a white paper?
Yep.
Very good. So that looks like a complex program to generate for a 6-axis robot. How'd you do it?
Well, there's multiple ways. By hand is not one of them.
No teach and repeat?
No. So you can either use offline programming software or math. So most shapes have a mathematical formula. Once you know that formula, you can put it in the robot, and with that formula, create as many points as you need to.
Okay, is this pulse, spray, or short arc?
This was short arc.
Why'd you pick short arc?
It's the coldest of the process because I want as few oxides as possible.
I see.
So this helped with that.
So this seems to be a great technique if you want thin shapes. So what is this, about 3/16 thick,
Yep.
3/16 wall? Okay. Are we doing any work on heavier sections?
Yes, we've done some strip and some sub-arc in the past, and so those are much bigger, 30 millimeter wide strip. So you can really get anything in between 332 to inch wide, 2-inch wide.
And that's something we're trying to do that's a little bit different. Most additive systems have a single bead size, so to speak, and we're coming up with multiple tools. So if you need heavy sections, we can do that with strip. If we need thin sections, we can do it with wire. So it's kind of like painting with a big brush and then a fine brush at the same time. So what's next?
I think next is try everything in between everything between 30 millimeter strip and 035 wire, and try some weaving, different gases, different materials, some Inconel, go some steel.
So sounds like you're ready to build parts.
Yeah, I think so.
Well, Jim, we're looking forward to seeing what you come up with next. So this is Dan Alford.
And Jim Walker.
We'll see you soon.